Part 2, finding an inverse matrix. Finding the inverse of an n by n matrix A. First, form the augmented matrix with the matrix A on the left side and on the right side the identity matrix of the same size. Then use row operations to transform the matrix to reduced row echelon form. Then, if the identity matrix does not appear on the left side of your transformed matrix, then it does not have an inverse. But if the identity matrix is on the left side after it's in reduced row echelon form, then the matrix is invertible and the inverse matrix is on the right side. So to do that, the very first step to set up the augmented matrix here, if we want to find the inverse, I'm going to write that matrix A and then write the identity matrix next to it. So it's all in one matrix. That is the augmented matrix. That's the first step. That's the first thing we do to find the inverse. Now we're going to use that same one, the same augmented matrix, and we are going to transform it into reduced row echelon form. So the first thing I'm going to do, I want a 1 in that top left column. I think the easiest way to do that in this case would be to switch the two rows. Remember, we can always switch the two rows of a matrix. Then I'm going to make that 2 that's underneath the 1 a 0. Right? I'm going to say the new row 2 will be negative 2 row 1 plus row 2. So my row 1 is staying the same for now. New row 2 is negative 2 row 1 plus row 2. So negative 2 times 1 plus 2 is 0. Negative 2 times 3 plus 5 is negative 1. Negative 2 times 0 plus 1 is 1. And negative 2 times 1 plus 0 is negative 2. Now I need this number to be 1. So I'm going to say my new row 2 will be negative the old row 2. I can multiply that whole row by negative 1. And then I need to make this 3 0. So the new row 1 will be negative 3 row 2 plus row 1. So row 2 is staying the same this time. Row 1, negative 3 row 2 plus row 1. So negative 3 times 0 plus 1. Negative 3 times 1 plus 3. Negative 3 times negative 1 plus 0. And negative 3 times 2 plus 1. Okay, so now the identity matrix is on the left. So the inverse matrix of A inverse is what's on the right. 3, negative 5, negative 1, 2. And we found the inverse of A. Let's try this again with this matrix, which is a 3 by 3 matrix, so it will take a little bit longer. I would encourage you to stop now. Try this on your own. Make sure you can do it. Okay, so the first thing I'm going to do is write the augmented matrix. That means I put the identity matrix to the right of this matrix B. And then I'm going to use the row operations to transform this into reduced row echelon form. So first thing I'm going to do is this has to be a 1. It already is. I'm going to make the things underneath of it 0. So the new row 3 will be negative 2 row 1 plus row 3. So row 1 and 2 stay the same. And row 3 becomes negative 2 times 1 plus 2 is 0. Negative 2 times negative 1 plus 3 is 5. Then we get negative 2, 0, 1. The next thing I need to do is make this a 1, and I'm going to do that by multiplying that row by 1/2. So for that row now I have 1, negative 1/2, 0, 1/2, 0. And if you'd rather use 0.5, if you'd rather use a decimal than fractions, that's just fine. That works the same. Then I'm going to make these two numbers 0. So my new row 1 will be row 2 plus row 1. And my new row 3 will be negative 5 row 2 plus row 3. So row 2 staying the same. Row 1 becomes 1, 0, 1/2, 1, 1/2, 0. And row 3 becomes 0, 0, 1/2, negative 2, negative 5/2, 1. And then from here, I need to make this a 1. So I'm going to multiply that row by 2. So the first two rows are staying the same. And then the bottom row now is 1, -4, -5, 2. Okay, I'm almost there. I just need to make these two zeros now. So the new row 1 will be -1/2 row 3 plus row 1. And the new row 2 will be 1/2 row 3 plus row 2. So row 3 is staying the same. New row 1 is 1, 0, 0, 3, 3, -1. And new row 2, 0, 1, 0, -2, -2, 1. So B inverse is what happened on the right. So on the left we have the identity matrix. So this does have an inverse, and the inverse would be the matrix that has these entries that are on the right.